Disclaimer on this video where I'm not a statistician. I've taken a couple statistics classes, but I'm going to say a lot of things that are incorrect. I'm just trying to base it off of this really complex reading. It's just thrown into the syllabus. And I don't think, honestly, you're supposed to understand a lot of the intense statistics on it. So I'm just trying to get a summary of the basics right here. So there's three things that they compare. They compare one-way analysis briefly, and then they compare linear models versus generalized linear models. And one-way analysis, this is where you just use one variable to predict the result. And so an example is your loss ratio. It's like, okay, my loss ratio, I'm just going to predict what the outcome is based off of this. And the issue is that there's no correlation between variables. It doesn't account for interdependencies between a factor and the result. And so yeah, we could understand this. So like one variable changes, how is that going to affect the other? And so the solution is, the first step is you could say, hey, what about we establish a linear model? I discussed in another video how to do this. I think this is what the systematic component is. Don't count on that. So this is just basically saying like, hey, your first variable, you times that by 0 or 1, whether that's true or not, and then you just keep going, and then there's always an error term. So this linear model, it assumes normality with each variable. And so what does that mean? So if I'm going to draw a graph right here, and let's say that I have some results, they're right here. It's going to assume normality, which is going to just try to reduce the error term between all of them. So we're going to find, imagine this as a straight line right there, but it's just going to try to get, just going to try to predict it with the least amount of variance right there. And that can be a really good thing. It's just basically, it just takes its partial derivatives of each of these variables, each of these predictors, and then it tries to minimize the error term, which is trying to minimize the standard deviation. And so that's what this is. And then for the generalized linear model, you can use any distribution with the prediction variables. So you can use like a gamma. This has its advantages. I'm going to draw this one in this rainbow color right here. So it gets closer right here, and then it just recognizes that it's a little bit further away from the error term there. And so it just tries to centralize like getting the prediction of the errors right here in the beginning. And then it gets a little bit further, which has its advantages when things are like in severity models. You have less information about things that are more intense later on, and so you just recognize that you're going to have more variance there, such as a car crash. The more severe the car crash is, the more variance there is in the claim cost. So that's what it's saying. So a gamma can be very beneficial to do, whereas the normal may not be as beneficial. It must be monotonic and differentiable. So that's true for the linear model or the generalized linear model. What does that mean? Monotonic means it's smooth, going up or down, so you can't have, and it's just constantly increasing or constantly decreasing. So that's none of this right there. And it must be differentiable. You'll see that I have like a crooked line right there. That's what differentiable it means. It means it needs to be smooth like that. And let's see. So linear models, variables are required to be additive. That's not necessarily a good thing because you might want it to be multiplicative too. It's mentioned in the reading, like the area of the wing of a butterfly. You don't want the length and the width to be two variables and then adding them to get the area. You want to multiply them. The length function I mentioned here, I don't really understand what that means. So the disadvantage of the linear model is a lot of these things right here. Is you have to assume normality, whereas this one you don't have to. Linear models are easier to implement, and only one model select, the normal distribution. Generalized linear models are harder to implement, and you have more model risk on deciding on a model. And then just recognize this one right here too. So this is really important to recognize.